The assault rifle is the foundational arm of modern infantry combat, engineered specifically to bridge the gap between long-range, heavy recoiling battle rifles and short-range, light-firing submachine guns. To achieve this balance, an assault rifle must fulfill 4 non-negotiable criteria. It must be an individual shoulder-fired weapon, possess selective fire capability, allowing the shooter to switch between semi-automatic and full automatic modes, feed from a high-capacity detachable magazine, and fire an intermediate cartridge that retains lethal ballistic energy out to 300 to 400 meters. While keeping recoil controllable, during rapid fire, engineers designing these weapons face an unforgiving physical puzzle. They must harness chamber pressures exceeding 50,000 pounds per square inch, delay the opening of the breech long enough for internal barrel pressures to drop to safe levels, reliably extract fired brass, eject spent casings, and feed a fresh cartridge into the chamber, all in a fraction of a second. Crucially, these complex mechanical sequences must function continuously inside extreme operational environments, surviving fine desert sand, freezing mud, torrential rain, and the thermal expansion caused by rapid continuous firing. In this definitive guide, we are examining 10 of history's most influential assault rifles, breaking down their exact mechanical operating systems, internal lockup actions, materials engineering, and real-world combat evolutions so that no technical detail is left behind. Beretta AR-7090, adopted in 1990 as Italy's primary infantry service rifle, the Beretta AR-7090 was built to conform with NATO standardization protocols while delivering extreme structural durability. At its core, the AR-7090 operates using a traditional long-stroke gas piston system, paired with a heavy 2-lug rotating bolt. When a 5.56 45mm NATO SS-109 cartridge is fired, high-pressure propellant gas travels down the barrel behind the bullet until it reaches a gas port located near the front sight assembly. A portion of this gas bleeds through the port into the gas cylinder, expanding against the head of a full-length piston rod that is rigidly connected to the bolt carrier assembly. The gas pressure drives the piston rod and bolt carrier rearward over a long mechanical travel distance. An angled cam track cut into the carrier forces the bolt head to rotate counterclockwise, unlocking its 2 heavy locking lugs from the barrel extension. As the bolt carrier continues rearward, it pulls the spent cartridge case out of the chamber via a spring-loaded extractor claw, flings it clear via a fixed ejector pin, and compresses the main recoil spring inside the receiver. Instead of using thin sheet metal stampings or lightweight polymer housings for the main receiver, Beretta constructed the AR-7090 using high-tensile stamped steel, reinforced with a rigid, trapezoidal cross-section upper receiver. This heavy-duty steel design pushed the rifle's unloaded weight past 9 pounds, making it heavier than competing NATO rifles. But it provided incredible structural rigidity, preventing receiver flex and housing distortion under intense automatic fire. Beretta integrated a manual 2-position gas regulator on the front gas block. Setting 1 provided standard gas flow for normal operations, while setting 2 opened the port wider to dump extra gas energy into the system. If heavy carbon buildup or mud slowed down the action, the gas block also featured a fold-up valve, cut-off switch that completely blocked gas from entering the piston chamber, redirecting all propellant energy forward to allow the rifle to safely launch. 22mm rifle grenades, directly off the muzzle, equipped with an integrated carrying handle, a built-in folding bipod, and full Stanag magazine compatibility, the AR-7090 remains one of the most mechanically forgiving, rugged Cold War service rifles ever manufactured. Heckler and Koch G36. In the mid-1990s, the German Bundeswehr needed a modern, lightweight replacement for its heavy 7.62mm G3 battle rifle, leading Heckler and Koch to design the G36. Moving away from their legacy roller-delayed blowback systems, HK engineered the G36 around a clean-running, short-stroke gas piston operating system. conceptually derived from the American AR-18. When fired, propellant gas enters a gas block above the barrel and strikes a small, independent piston face. Instead of riding the entire distance back with the bolt carrier, this short-stroke piston delivers a brief, sharp mechanical tap against the front face of the bolt carrier, transferring backward kinetic momentum before a small return spring instantly snaps the piston back forward. The bolt carrier glides rearward under its own inertia, using an internal helical gem slot to rotate and unlock a multilug bolt head from the barrel extension, because the gas piston vents all expanding gas and carbon residue out forward near the front sight block rather than blowing it backward into the receiver. The receiver core and bolt carrier stay exceptionally clean and cool during extended range sessions. To drastically reduce overall infantry weight, HK molded the G-36's entire receiver shell, rigger housing, magazine well, and side-folding buttstock out of a high-strength, glass fiber-reinforced polyamide polymer. Steel inserts were cast directly into the polymer, frame only at high-wear contact zones, such as the barrel trunnion interface and internal bolt guide tracks. Original military-issue G-36 models came fitted with a dual optic carry handle containing a primary 3X optical scope nestled directly beneath a battery-powered red dot. Reflex sight for close quarters targeting. However, extended combat engagements in Afghanistan revealed a critical thermodynamic vulnerability under continuous rapid automatic fire in high ambient temperatures. Heat from the barrel trunnion transferred directly into the surrounding polymer receiver housing. As the polymer reached its glass transition temperature, the material softened slightly, allowing the steel barrel trunnion to shift micromillimeters out of axis under firing recoil, and causing severe optical zero wandering at distances beyond 200 meters. This thermal distortion issue generated intense international debate and ultimately prompted Germany to begin replacing the G-36 with the all-metal HK-416 platform. FAMAS F1 and G2, France's FAMAS, formerly standing for Fusil d'assaut de la manufacture d'armes de Saint-Étienne, entered service in the late 1970s and earned the universal nickname Le Clairon, the bugle. Due to its high-carrying handle frame, the FAMAS was built around a bullpup configuration, relocating the firing action chamber and magazine well completely behind the pistol grip and trigger mechanism into the buttstock area. This packaging trick allowed French engineers to fit a full 19-inch rifle barrel inside a weapon with an overall length of just 29.5 inches, delivering full ballistic velocity in a tight, maneuverable package. Mechanically, the FAMAS ignored conventional gas ports, piston rods and direct gas tubes entirely, operating instead via a rare, lever-delayed blowback mechanism designed by engineer Paul Tellier. When a 5.56-meter cartridge detonates in the chamber, high chamber pressure immediately forces the spent brass casing backward against the bolt head. The bolt assembly is divided into two distinct components, a lightweight front bolt head and a heavy rear bolt carrier, linked together by a central two-pronged mechanical delaying lever. As the bolt head attempts to slide backward under initial chamber pressure, the lower leg of the delaying lever rests against a hardened shoulder in the receiver wall, while the upper arm pushes against the heavy bolt carrier. Through leverage physics, the movement of the bolt head is mechanically restricted, forcing it to push the much heavier bolt carrier backward at a higher velocity ratio before the bolt head itself can fully retract. This mechanical leverage delays the full opening of the breech for a precise fraction of a millisecond, keeping the action sealed until bullet exit drops. Chamber pressures to atmospheric safety, to prevent the high-pressure brass casing from sticking or tearing against the chamber walls during this immediate delayed recoil movement. Engineers cut longitudinal flutes into the chamber walls, allowing a small cushion of high-pressure combustion gas to flow around the outside of the casing. To float it clear of the metal, the original FAMAS F1 variant required proprietary 25-round steel magazines and heavy, steel-cased French M193 ammunition. Standard soft brass NATO rounds would rupture inside the fluted chamber. Due to the rapid extraction timing, in the 1990s, France developed the famas G2 variant, which modified the lever geometry, upgraded the extractor claw, integrated an enlarged trigger guard to accommodate heavy combat gloves, and accepted standard 30-round NATO Stanag magazines loaded with brass-cased SS-109 ammunition. Steyr Auge, introduced in 1977 by Austria, the Steyr Auge Armee Universal Gewehr, set the global gold standard for modular, operational bullpup rifle architecture. The internal mechanism of the AUG utilizes a short-stroke gas piston mounted off-center. To the right side of the barrel, expanding gas strikes the piston, driving two solid steel guide rods rearward through internal channels in the receiver frame. The left guide rod acts as the cocking link connected to the charging handle, while the right guide rod directly contacts the bolt carrier, pushing it rearward to rotate and unlock a 7-lug rotating bolt head. These dual guide rods ride on self-lubricating synthetic bushings inside the polymer receiver, guided by twin recoil springs housed within the rear buttstock. The AUG's single most impressive engineering breakthrough is its toolless, quick-change barrel system. By depressing a spring-loaded steel lockpin located on the gas block and using the vertical foregrip to rotate the barrel 45 degrees counterclockwise, a shooter can unlock the barrel's locking lugs from the receiver trunnion and pull the barrel clean off the gun in under 3 seconds. This modularity allowed infantrymen to instantly swap between a short 14-inch commando barrel, a standard 20-inch rifle barrel, or a heavy 24-inch light machine gun barrel, fitted with an integral bipod. To simplify operation, early AUG models eliminated a traditional manual fire selector lever, opting instead for a 2-stage progressive trigger system. Pulling the trigger back halfway to a noticeable pressure wall released the internal hammer, for a single semi-automatic shot. Pulling the trigger all the way through the pressure wall past the stop engaged continuous full automatic fire. The AUG's outer housing was molded from high impact green structural polymer containing an integral Swarovski 1 Peaks optical sight built directly into the carry handle frame. This optics integration provided a wide field of view and an etched ring reticle designed for rapid target acquisition, ensuring combat readiness regardless of moisture or environmental dust exposure. Daewoo K2. During the post-Vietnam era, South Korea determined the total reliance on imported foreign small arms presented a strategic defense risk, leading to the development of the indigenous Daewoo K2 assault rifle. South Korean engineers designed the K2 as a hybrid platform, systematically combining the best mechanical attributes of American and Soviet infantry weapons into a single receiver. The external layout: low receiver controls, thumb-operated safety selector, multi-lug rotating bolt head, and 5.645 mm. NATO chambering were borrowed directly from the American AR-15 M16 architecture. However, the K2 completely discarded the M16's internal direct gas impingement system, replacing it with the heavy, ultra-reliable long-stroke gas piston system of the Soviet AK-47. A solid steel piston rod is permanently riveted to the top of the heavy bolt carrier assembly. When a round is fired, gas bleeds into the top gas cylinder, slamming the piston rod rearward with massive kinetic energy. Because the heavy gas piston drives the bolt carrier rearward with high momentum, the rotating bolt easily rips through carbon buildup, sand, and frozen condensation that would freeze lighter direct gas actions. This hybrid layout solved the cycling failures that early direct impingement rifles experienced in wet, tropical environments. While retaining familiar American ergonomics and target accuracy, the K2's recoil spring is contained entirely inside the upper receiver frame, allowing the weapon to use a side-folding polymer buttstock that locks flush along the right side of the receiver, a feat impossible on standard M16s due to their buffer tube extensions. Featuring a 4-position fire selector with an internal ratcheted 3-round burst mechanism and a 3-position gas plug regulator. The Daewoo K2 remains a masterclass in hybrid mechanical engineering.